The speed of a stream is 5 miles per hour. If a boat travels 54 miles downstream in the same time that it takes to travel 27 miles upstream, what is the speed of the boat in still water? Well, a really good first step in any word problem is to state the unknown. And since we're being asked to find the speed of the boat in still water, that is our unknown. So let's go ahead and start by letting x equal the speed of the boat in still water. This type of problem actually has a common name. We often refer to these as motion problems. They involve distances, rates, and times. And because of that, we will often use the distance equals rate times time formula in order to solve these kinds of problems. And a common strategy is to create a chart based on this formula and the information given in the problem. And what that does is it allows us to organize our information, kind of get an idea of what's going on, and then go from there so that we can solve the problem. So let's go ahead and do that for this particular problem. Here's what the chart will look like. We have a downstream trip and an upstream trip. And we use the formula distance equals rate times time to represent the headers of our chart. Now we use the information given in the problem to complete the chart as best we can. So notice right off the bat in the problem we're told that the boat travels 54 miles downstream. So that tells me that my distance downstream is 54. And then we're told that the boat travels 27 miles upstream. So the distance for the upstream field is 27. Now for the rate, when a boat's going downstream, it's going with the current. And so it's as if the boat is going the speed that it would in still water, but it's being helped along by the current. And in this case, we're being told that the speed of the stream is 5 miles an hour. So we can represent the rate of the boat going downstream with the expression x plus 5. In a similar way, we can allow the rate of the boat going upstream to be represented by the expression x minus 5. So it's the speed of the boat in still water, but since the boat is fighting the current going upstream, we take that 5 miles an hour off of that speed. And so we end up with the expression x minus 5. Now, in terms of the time, we are not told the time that it takes for the boat to travel downstream or upstream, but we are told that the time is the same. Okay, so from here, where do we go? Well, I know that the time is the same, and if I take my distance equals rate times time formula and divide both sides by r, I get a modified version of this formula, which is t equals distance over rate. What this is going to allow me to do is to create two equations representing the time downstream and the time upstream. So let's put all this together. An equation that represents the time going downstream is t equals and then distance divided by rate. Well, the distance going downstream is 54 and the rate we represented by the expression x plus 5. Now we can create an equation to represent the time going upstream, t equals, and then the distance divided by the rate for the upstream trip would be 27 divided by x minus 5. Now, since we're told that these times are the same, in other words, these times are equal, all we have to do is set these expressions equal to each other and solve. Solving this equation for x, notice that's actually going to give us the answer to our problem, since we, in the very first step of this problem, allowed x to equal the speed of the boat in still water. So since the speed of the boat in still water is what we're trying to find in order to answer the question, and we allowed that value to be represented by x, that implies that solving this equation for x will give us the solution that we're after. So there's a couple different ways that you can solve this equation. I'm just going to use the good old-fashioned method of cross multiplying. And so what I'm going to do is multiply 54 times x minus 5 and set that equal to 27 times x plus 5. And then I will distribute on both the left and the right hand side, which gives me 54x minus 54 times 5 is 270. And then on the right side, distributing the 27 gives me 27x, and 27 times 5 is 135. I'm almost home free here. So I'm going to subtract 27x from both sides to get all my variable terms on the left. That gives me 27x minus 270 equals 135. Then in order to get all of my numerical terms on the right hand side, I'm going to add 270 to both sides. And that gives me 27x equal to 135 plus 270 is 405. And we're almost there. The last step is to divide both sides by 27. And the result is x equal, and 405 divided by 27 is 15. So the speed of the boat in still water is 15 miles per hour. Now, just as an added note before we end this, going back up, we were able to set these two expressions equal to each other. We were able to set the two expressions that represented time equal to each other because in the original problem, we were told that the time going upstream and the time going downstream was equal. And so that made sense. Another way to look at this, if you want to apply the ideas in this unit, is that we really just solved this system of equations using substitution. In other words, it's kind of like we took the expression we took the expression 54 divided by x plus 5 and we substituted that in to the second equation for t. And so we set these two expressions equal to each other because the time we were told was the same, but it also jives with the information and the material in this unit because we simply just substituted 54 over x plus 5 for t, and we would have ended up in the same spot.